Hello guys, I welcome you all to Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now let's solve this one another problem from chapter first of Fundamentals of Physics by Halliday and Resnick. And the problem says that Antarctica is roughly semicircular with a radius of 2000 km. The average thickness of the ice cover is 3000 meter. How many cubic centimeter of the ice does Antarctica contain? Ignore the curvature of Earth. So we are given that the radius is 2000 kilometer and we are required to find the volume of the ice in cubic centimeter. So as we know that since it's a semicircle, so the area will be equal to the area of the full circle is pi r square. So it's a semicircle, so we need to divide by 2. So this is the area, and to find the volume of the ice, we can write that volume will be equal to the area times the thickness. So area multiplied by thickness. So this will be equal to pi r square divided by 2 multiplied by the ice thickness. So the ice thickness is given, that is equal to 3000 meters. So we need to have the volume, in cubic centimeters. So what we need to do is that we need to convert this radius and this thickness into centimeters first. So we are given that the radius is 2000 kilometer. So we know that we want to cancel out this kilometer, so we need to multiply it by a fraction and we need to divide it by kilometer, right? So in the denominator we need to have kilometers, and let's say that in the numerator we have meters. So now we know that 1 kilometer is equal to 10 raised to the power 3 meters. So while doing this, kilometer will cancel out, but still we have this meter and we want to convert this into centimeters. So again we need to cancel out this meters, so we will write meter in the denominator and we want to convert it into centimeters. So now we know that 1 meter is equal to 100 centimeter, or we can say that this is 10 raised to the power 2 centimeters. So this will cancel out and we will have 2000 into this will 10 raised to the power 3 into 10 raised to the power 2 will give us 10 raised to the power 5 centimeters. So this is the radius in centimeters. So it is 2000 multiplied by 10 raised to the power 5 centimeters. Now we need to convert this thickness into centimeters as well. So I will write T. So T is 3000 meters. Now again we need to cancel out meter, so we need to write meter in the denominator and centimeter in the numerator. So again 1 meter is equal to 10 raised to the power 2 centimeter, and meter will cancel out, so we can write that this will be 3000 into 10 raised to the power 2 centimeter. Now we can use that volume formula. This is that volume. We can use this volume formula. So volume is equal to pi divided by 2 r square. Now r is 2000 into 10 raised to the power 5 centimeters. So this is square multiplied by the thickness in centimeters. So this is thickness, which is 3000 into 10 raised to the power 2 centimeter. So we can write this as pi divided by 2, and this will be, let me split this 2000. So we can write this 2000 is 2 into 10 raised to the power 3 into 10 raised to the power 5 centimeters square, and this is, let's say, 3000 into 10 raised to the power 2 centimeters. So this will be 10 raised to the power 3 into 10 raised to the power 5 will be 10 raised to the power 8. So let's write this as 10 raised to the power 8. So now we can simplify this. This is pi divided by 2 2 to the power 2 multiplied by 10 raised to power 8 to the power 2, and this is 3000 into 10 raised to power 2, and this will become centimeter square, and this will become centimeter. So centimeter into centimeter square into centimeter will be cubic centimeter. So this is cubic centimeter. Now let's simplify this. This is pi divided by 2 multiplied by 4 multiplied by 10 raised to power. This will become 8 into 2, so that is 16, 10 raised to power 16. So 10 raised to power 16. Okay, let's multiply just the numbers, right? So this is pi divided by 2 multiplied by 4 multiplied by 3000. So this gives us volume equals to this is 18,850 approximately, and this will be, we will have this 10 to the power 16, and this is 10 raised to the power 2. So 10 raised to the power 16 plus 2 will give us 10 raised to the power 18 centimeter cube. Now the given data is given in terms of four significant figures. This is 4 significant figures, so we need to have our answer in 4 significant figures as well. We have these 5 figures, right? So for that, what we need to do is that we need to multiply and divide this by 10 into 10 raised to the power 18 centimeter cube. So when I divide this by 10, so this 0 will cancel out and we will be left with 1885. So this is 1885, and this is 10 raised to the power 1 plus 18, so this will give us 10 raised to the power 19. So this is 1885 into 10 raised to the power 19 cubic centimeter. So this will be the volume of the ice. Now the next problem is problem 10, and the problem 10 says that this is the problem 10. It says that until 1883 every city and town in the United States kept its own local time. Today travelers reset their watches only when time change equals 1 hour. How far on the average must you travel in degrees of longitude between the time zone boundaries at which your watch must be reset by 1 hour? And the hint is given that Earth rotates 360 degrees in about 24 hours. So we are given that 360 degree is equal to 24 hours, or we can say that 24 hours is equal to 360 degrees. So this means that for complete revolution of the Earth, the time taken is 24 hours. So we need to reset our watches every 1 hour, right? So every 1 hour change requires the reset of the watch. So we need to find the angle for 1 hour, right? So for 1 hour we need to divide both sides of equation by 24. So this will be 1 hour, and 360 divided by 24 gives us 15 degrees. So for every 15 degrees we need to reset our watches. So for every 15 degree revolution of the Earth, the watches need to be reset. Now the next problem is problem 12, and the problem 12 says that the fast growing plant on record is some plant that grew 3.7 meter in 14 days, right? So the growth is, let me write that the growth of this particular plant is 3.7 meters per 14 days. So it is said that what was its growth rate in micrometers per second? What was its growth in micrometers per second? So we need this growth in micrometer per second. So we need to convert this meter into micrometer and this days into seconds. So for this I will write that growth is equal to 3.7 meters divided by 14 days. So now we need to cancel out these days, right? We need to cancel out these days. We want to convert these days into seconds, right? So we will write that day into hours, right? So we know that 1 day is equal to 24 hours, so day will cancel out. Then we want to convert this hour into seconds, right? So we know that 1 hour, we know the conversion between hour and seconds directly, so we know that 1 hour is 3600 seconds. So we need to write this hour in the numerator in order to cancel it, right? So this hour will cancel out. So we have changed this days into seconds, and we need seconds in the numerator, so we have that second in the numerator. Next we need to convert these meters into micrometers. So now we know that 1 micrometer, let me write that, 1 micrometer is equal to 10 raised to the power minus 6 meters. We have this conversion, right? So we want to cancel out this meters which is in the numerator, so we need to multiply it by a fraction, and in the denominator we need to have meters, and in the numerator we need to have micrometers. Now we know that 1 micrometer is 10 raised to the power minus 6 meters, so this meter will cancel out as well. So at the end we are left with micrometer per second. So now let's multiply all these. We have 3.7 divided by 14 multiply by 1 divided by 24 multiply by 1 divided by 3600 multiply by 1 divided by 10 raised to the power minus 6. And if I bring this 10 raised to the power minus 6 to the numerator, so it will become plus 10 raised to the power 6, right? So this will be 10 raised to the power plus 6, and this at the end we will have the units in micrometer per second. So now let's multiply all these. So first of all we have 3.7 divided by 14 multiply by 1 divided by 24 multiply by 1 divided by 3600 and multiply by 10 raised to the power 6. So at the end we have 10 raised to the power 6. So this gives us 3.05. This is equal to, this is, let's say, approximately 3.06 micrometer per second. So now in the problem statement the given data is 3.7 meters in 14 days. So it is of two significant figures, so we need to have two significant figures in our answer as well. So we can say that this is approximately 3.1. So the growth is 3.1 micrometer per second. So that particular plant growth was 3.1 micrometer for every seconds. So this is the solution of these three problems. I hope it will help you in your learning. Let me know in the comments if it helps in your learning. Also subscribe Engineers Academy for the solution of such more problems from fundamentals of physics.